Next, we need to compile. We need to compile. Okay, compile the model. You compile the model with, now we have to define error. About errors, for categorical data, we usually use a categorical cross-entry loss function. A categorical cross-entry function, categorical cross-entry function, cross-entry loss function, cross-entry loss function, cross-entry loss function. And then what optimizer? Other delta optimizer. We need the optimizer to training, and the accuracy metric. Okay, we have the accuracy so that we can see how accurate we are. Okay, and then we will feed the data to the model. Okay, so we train the model with, let's say, 15 epochs, 15 times. Okay, just 15. I mean, we have to do more, but to save time, we'll just 15 times. And then after the training, then we have to evaluate the loss and accuracy of the model. We will evaluate loss and accuracy of the model where? On the test dataset, right? On the test dataset, not training dataset, right? So we are going to do this one. So, well, we have to compile. So we have to model. We have to model, compile. You have to model, compile. Okay. And then we'll define loss function. Loss is what? Loss is it is the categorical cross entropy. Loss is categorical cross entropy. Okay, good. Okay, and then we will do optimizer. Optimizer is Keras optimizers, and then Ida delta. Okay, good. Okay, and then we will use the metric, accuracy metric. So metrics, and then we will see accuracy. We will see the accuracy metrics. Okay, and then epoch is how many epochs? Our epochs is, we'll say 15 times, only 15 times of training. And then batch size. For each training, we will feed this number of data. Okay. And then we will fit the model. So to fit the model, now we have to fit the model. So model, fit the model. And then in fitting the model, we will training set. We will fit the training set to the X to Y. Okay. And then batch size is batch size, which is 128. And then epochs, how many we run epochs is epochs epoch, right? And then I want to see the result. So for both equals 1, 0 it is quiet, 1 it shows the result, and then we have to specify validation data. Validation data is of course X test and then Y test. Okay, X test, Y test. The score about the accuracy metric will model, evaluate, and then when we evaluate, model evaluate. When we will evaluate, we have to evaluate at where? Testing set, right? X test, Y test. One. So let's run it. Okay, so we have error, metric accuracy, metrics and accuracy, eta delta, and then I think, okay, so first run, wow, it is very slow. Okay, sorry, let me stop, and then I change the runtime, change runtime type into the GPU, save. And then I'll run entire again. Okay, it should be faster. So yes, 15, 1, the first one is, yes, it is faster, of course, faster. So loss is 47, accuracy is just 10%. Now, accuracy is actually lower, accuracy even lower. Well, but accuracy here, accuracy getting improving. You know, as you training, not always improving, but initially it accuracy decreasing, but now it accuracy increasing, accuracy getting better and better. And now accuracy is like a 30%. Loss is, initial loss is like 47, now loss is 2. Accuracy increasing, and then 13 accuracy 40%, almost 40%. And then accuracy 45%. Here, loss this one accuracy as 55%. Okay, well, we can do like 150, then it would be more accurate, but then, you know, it will take too much time. So yes. So here, the score like this. So let me take a look at the result more. Okay. So more. So print score. If we print the score like this one, but let me print the first one. First one is test rows, and then score 0, and then print 1. Next one is test accuracy. Accuracy as test set. I'll put this one. Test one is the score 1. So, wow, no, it is the. So here, test rules is this one. Test accuracy is 55. It is a bit. It is actually very low, very low. But you know, I didn't do much learning, and the network is very simple. Let me increase epoch to the 20 times. Then would it be better? Let me try. So we have to wait. While we are waiting, let me add the code. code. Okay. I will do code. And then let me check the prediction. Okay, so model predict. Okay, model predict. And then if we put the test set, X test. Okay, almost. Model predict, X test, and then 2, right? And then let me say, okay, now test accuracy is a bit or higher because I did 20 times of the running, so like 74%. Okay, now about model prediction, I'll do predict, and then let me tabulate the result. Tabulate, and then actually I'll float format. Actually, float format equal to float format is to the second one, and then print. Okay, so in the test set, I plug in the first three images, and then the result is that first three images, and then the result is that, well, again, it's softmax function, so it gives us the probability. So with 99%, it says it is 7. The first one is 7. And then here at the 2% about the second image, is not fun, let's say, of the third one. Okay, so 99%. It is like 70 up to 76%. 76% is 2, and 20% it is 3. Like 2% it is 3. How about this one? About third image, for the third test image, it is 86% of the 1, right? And then well, 5% of the 2, interesting, and 5% of the 4. How about the actual result? Let's see the actual result. Print, and then let's see the actual result. Test set. Y test. So, okay. So, yes, 90% it is correct. And then it is correct. And it is roughly, it is, well, it is 75%, but it seems that, well, with the highest score is match the correct answer. So this seems a bit correct, right? And then how about we actually see the image? Actually, I'm become curious about actually seeing the image of the T1. So yeah, actually, image show, image show, and then let's see Y test. Let me see the second one, first one. PLT IM show. PLT IM show. Yeah. Sorry. Y test, X test. So it is the, actually, well, here I cannot see it very well because, well, it is the, I reshaped it, right? I reshaped it. So, yeah, I reshaped it. So, well, I reshaped it. So, thing is that, of course, well, I can simply this one again. Okay. Well, and then I will, okay, first, okay, and then I'll do this one, and then let me see, X test. Let's see the very first one, first one 7, right? This is clearly 7. So, well, we talk computer, this network 99% 7, and then it has what? It has 1% of 4. Well, it doesn't. So it's very easy to understand. How about the, so 99% correct. And then this is the 7. And then this one is 2, but it has some difficulty. It is between 2 and about 20, assigned 20% into 3. So let's take a look at it. And then looks like this. So where 2, it is clearly 2, but where 2 and 3 has some similarity to each other. So it is no wonder that this network is a bit confused between 2 and 3 about this one. Okay. How about this image? Okay, so well, it is clearly. How about, let me check. Yeah, something like this. So well, it is clearly, yeah, no problem about that. This is easy to predict. Okay, so this is the end of the practice for convolutional neural network.